Did you know that you could predict the future with Prometheus? This video gives you a deep dive into the predict linear function and how basic machine learning works. Let's get into it. You may want to know if some negative situation will happen in the future based on the current trend. For example, if your web server will run out of available disk space. PromQL can predict the future using machine learning. The predict linear function projects a series into the future. For example, this query predicts the free disk bytes 24 hours from now based on the trend of the last 6 hours. If the result is less than 0, it means that based on the current trajectory, the disk will be full in one day. This trick enables proactive alerts, which are far more nuanced than static thresholds. But before we can see how predict linear works, let's examine what machine learning is. There are two types of machine learning: supervised and unsupervised learning. In this video, I'll introduce you to one type of supervised learning called linear regression. With linear regression, a machine can predict future values given historical trends or data. Does that already sound familiar? Good. Let's say you have a table of house prices and you want to determine future house prices given current market data. You can plot every example X or price you have. The aim of linear regression is to then fit a line through this graph. Using this new line, you can then predict the value of the y-axis for any value of X. The basic formula for linear regression is given as shown on the screen. The parameter W is the slope and B is the intercept. Once you find these values, you can run a basic form of prediction. In mathematics and statistics, you've probably heard this named the line of best fit. There is more to this form of prediction though. We generally also need a way to evaluate our predictions to make them as accurate as possible. These optimization algorithms look at how close predictions are to the known true values and reduce this cost as much as possible. A common example of this is gradient descent. Optimization algorithms are beyond the scope of this video. Now let's get back to predict linear. How does it work? I have set up a Jupyter notebook to help you understand. If you want to go through the full notebook, I have linked the GitHub repository in the video description. It has all the instructions for you to get started. Let's explore how the predict linear function provides a basic form of machine learning with linear regression. To make a prediction using linear regression, we need to find the values of two variables, the slope and the intercept. Using these parameters, we can predict future values given new inputs. I have written some code to replicate what predict linear does. To see the full code, feel free to check the repository in the description. The first step is to load the Prometheus data, which I have stored as JSON from Prometheus queries. In our upcoming examples, we will predict when there will be no disk space left on the server based on data from a 6-hour window. We pull the JSON in and convert it to the correct representation, a pair of the timestamp and the value. We then replicate what predict linear does by fetching the values of the slope and the intercept. The slope is obtained by dividing the covariance by the variance. If you are wondering what those terms mean, don't worry about it. You don't need them to understand what is happening in the rest of the video. Another interesting observation is that the Prometheus logic uses k-hand sums, which help reduce errors in mathematical computations by keeping track of the remainders. So now we have obtained values for the slope and intercept. It's time to predict the future. We can look t seconds into the future by simply multiplying the slope by the number of seconds into the future and adding the intercept. We then combine all of this and generate plots to show our results. Let's see what we can learn from how predict linear predicts the future for various patterns of disk space. In the first scenario, the space available is slowly decreasing. The 1-hour prediction shows a steady rate of decrease, and the 24-hour prediction is lower and decreases much quicker. This is because we've normalized the time values so we can show them side by side, which is just for illustration. When we have a bursty pattern, it's a bit trickier but the overall pattern remains the same. Over the 6 hours of data we have, the disk space is still reducing at a similar rate as the first scenario. This is why the predictions for the future are similar. In the next scenario, the disk usage remains the same for a while, then suddenly drops. The result of this is an overall lower prediction than the previous scenarios, since the later values are much lower. This pattern is not exactly linear, and the disk usage may suddenly spike again. This is a drawback of using basic linear regression. You may need more data, or the data just doesn't fit. There are techniques to improve the fit though, such as using higher order polynomials in our formula. We may talk about that in upcoming videos. For the sawtooth pattern, we have a similar conclusion to scenario 2. Even with the sharp spikes and dips, the overall space is still decreasing at a steady rate. And finally, I have included an example where the available disk space is actually increasing at a steady rate. There are no surprises there. This concludes our exploration of predict linear for now. Please let me know if you have any questions in the comments.